we move to a next topic given by Professor Yun. Professor Yun was educated at the Seoul National University in Korea, and later he moved over to Canada to achieve his PhD in the field of immune modulation and mucosal immunology. Then later you pursued your professor career, and you were leading different institutes like the Vaccine Institute in Korea, an institute at the USDA at Göteborg University in Sweden. Professor Yun will talk on the topic immunological and nutritional aspects of inflammatory response in pig. Professor Yun, please.
Yeah, as soon as I have my slide on it, then I'll start. But I guess, this one, well, I'm not sure, okay. And continue? Yeah. Okay, here we go. Thank you very much, Franz and Andre, for sharing a nice introduction. Good afternoon, ladies and gentlemen. Cheol-Heui Yun at Seoul National University, Korea. Today I'm going to talk about immunological and nutritional aspect of inflammatory response in pigs. But before I start, I would like to thank the organizing committee at Biomin, including Biomin Korea. I'm very honored to be here and to discuss some of the things that I think is very important, not only in pigs, but perhaps domestic animals in general. I've been informed that I shouldn't go too extensive introductions. I have only 4 slides for introduction and stress in pigs, and I'll get the point where I think nutritional aspect of inflammation that we can discuss later in that part, and followed by conclusion. So I think we've heard all of these things that many of you, or most all of you, would agree with me on current status on animal farming. Global warming, AGP, we just heard that. Disease, epidemic, endemic, it's broken. Opportunity, pathogens, and also vaccine. In a way, I regard the vaccine as a stressful condition, but different perspective is an insurance. Animal aiming at high productivity and all other stresses make me think that there are various psychological and physical stressful conditions on animal farming. And quickly move on to those stresses or stress conditions in pigs. Stress is a response to a stressor, such as an environmental condition or stimulus. It typically describes a negative or positive, although we always look and think and talk about the negative side of the story, can have an impact on our mental and physical well-being. Stressor is a root of stress. It's an agent, condition, or other stimulus that causes stress to an organism. Under this situation, we all know that they produce and induce stress hormone, glucocorticoid, which affect immune response or fitness of the body. If I have to categorize into different factors on stressors in pigs, nutritional factors, environmental factors, biological factors, and physical factors. Among them, unbalanced nutrient toxins and thermal stress, weaning and infection and vaccination, castration, transportation that we do have interest, which I'm not going to discuss today. So that is sort of introduction. Nutritional aspect of inflammation. And I decided not to describe anything about the nutrition because many or almost all of people in here would know about the nutrition. I have had only masters, so I think I go a little bit safe side. So move on to immunology right away, because in order to explain inflammation, I have to explain immunology. And this is 1-year lecture, and it's tough. And I have summarized in just 1 slide, so you're lucky. So when I look at these immune systems, we normally say that there are 2 arms. One is innate immunity, which is immediate response. So as soon as body sees the antigen, they attack and try to remove it. On the other hand, there's adaptive immune systems. Days to respond, it takes time, and it is all about the memory. So vaccination, we talk about vaccination a number of times It is about adaptive immunity. And that's a specific response by B cells and T cells. Whereas when you look at the innate immunity, it is integrate with adaptive immune system, which means that adaptive immunity cannot be there without having innate immunity. So innate immunity has to start first to have this efficacy of vaccination, for instance. I'll talk again a little bit about it later. And effector molecules which start this innate immunity, and most of them are about the inflammation. So I hope that this gives you an idea about this inflammation and immune system and efficacy of the vaccination, which I'm going to discuss more about it. And I'll talk a little bit about unique immune system in the pig at the close to the end of the presentation, so I'll skip this one. So inflammation is a body natural reaction to invasion by an infectious agent, toxin, physical, chemical, or traumatic damages. During this response, what happens is that it recruits immune cells by the action of chemokines and cytokines. Why they recruit? There are two important things. One, try to destroy and remove the threat. Two, it promotes healing process. Okay? And classical signs are, as we all know, heat, swelling, redness, pain, and loss of function. But when you look at the inflammation on the nutritional point of view, dietary energy and proteins are used in defense mechanism instead of being used for gross performance. And oftentimes we see they accompanied with sickness behavior, reduced feed intake, low feed efficiency, retardation of gross performance. Sorry. And also we know that upon this stressor, brain reacted to it, as I mentioned already, that they produce hormones. But now we also know that there are some link to immune system, and they produce or induce pro-inflammatory cytokines. IL-1 stands for interleukin-1, interleukin-6, tumor necrosis factor alpha, which are mainly produced by immune cells. So there is all linked together, stress, endocrine, and immune systems. And also in the pigs, when we look at it, weaning, thermal stress, infection, injury, mycotoxin, they increase the level of pro-inflammatory cytokines and also induce change of intestinal morphology and induce decreased feed intake and body weight gain. In short, mucosa dysfunction coincident with growth retardation in pigs. Of course, at the end of the day, we'll have economic loss. So now, is inflammation bad for pigs? Let me remind you again, in terms of the infection-related inflammation, it's a natural defense mechanism. It prevents spread of damaging agents to nearby tissues. And also, it disposes cell debris and pathogens, and it sets the stage for the repair process. And Ruslan at Yale University suggests that infection, tissue injury, tissue stress will induce inflammation. Our expectation is to have host defense, tissue repair, and adaptation to the stress. But if it fails, there will be tissue damage and fibrosis and development of non-infectious disease. So now the question, is inflammation bad? Maybe some of you slip through. I think I'll give you the answer first and then explain later a little bit more. I must say that not always. Not always. So we have pathogen and host system try to prevent and protect it. If we don't have inflammation, we wouldn't have any protection and defense against these infectious antigens. And vaccination, no efficacy of the vaccination. And therefore, for this resistance, prevent protection, we need to have inflammation. We can find many literatures. ROS could be beneficial under the certain circumstances. And inflammatory cytokines when it's at the adequate level, that could enhance the immune response. Adjuvant is necessary for vaccine use. They induce early inflammatory response. So for the vaccination, defense to attenuate antigen requires inflammation, which is necessary. As I said, it's because it recruits innate immune cells at the site of the vaccination. And this innate immune system is required for the activation of adaptive immune system. And therefore, they will have memory cell generation, antigen-specific antibody production, and then effector cell activation. And also, inflammation could become a threat as well. Under the certain conditions, invading agent is not removed, or inflammatory mediators are imbalanced, or sterile inflammation that I'll explain in the next slide. Because prolonged production of ROS and enzymes and all these effector molecules by mostly immune cells could harmful to the host. And on the other hand, the sterile inflammation indicates that it's nothing to do with infectious reagent. At the resting stage, you don't see them, or cells do not see them at all. They are inside the cells. But under the cellular stress or injury, cells will release those molecules, like ROS, ATPs, HMGB1, and that induces inflammation. So that's nothing to do with these pathogens. I have some problems with some of the studies. Barbara, where's Barbara? Not you, so don't worry about it, and don't be mad at me saying this. When I look through many studies by using piglets, when they design for the efficacy of or effect of feed additives, design goes something like this. Experimental scheme is to have controlled diet compared to diet with supplement, right? And then looking at all these different parameters, you weigh them, and then conclusion would be this. Well, get better. I have some problem with this, is that quite often what you see during this period is that there's weaning and or vaccination involved in that period. I see that as a problem. During this period, most vaccines are given, and inflammatory responses are probably necessary. So this is what you want, that I explained already. But if you have this anti-inflammatory reagent, it could be a problem. So I will say that to maximize the efficacy of vaccination, when and how becomes an important question. So when and how to set the regulation of anti-inflammatory response, I think is very critical. We need more and better immunological studies. I must say that comparative immunology would be a good idea for two reasons. One, it's well known in human and mouse. So we can take a concept from it and compare to it. But more importantly, what we found as we do more and more of domestic animal immunology, it's not always the same. So it's not the same, or not always the same. For that reason, I think we should work on this. There are some unique features. I'm not go through details of it, but there are differences in immune systems, pigs and humans, monocyte, macrophages, dendritic cells, and also microarray profiles suggest that there are some differences. And even in the adaptive immune systems, that certain cytokines produced by cells are different. And also when you look at the biomarker, then there are some subset. It's not exist in humans, but in pigs. And we look at the double positive T cells, CD4, CD8. We're not the first one to say it. We know that. But when we sort out and looking at some functions by addition of cytokines and mitogen, we found that cytokine profiles were different when compared to those of human and mouse. We need more proper biomarkers and diagnostic tools as well. I'm not going to talk about acute phase fluorescence today, but perhaps you would like to look at the recently published review paper in animal production science. It explains about this stress and acute phase proteins and immune regulation. So I think the balance is the key. The previous speakers all suggest that as well. Nutrition, immune response, and animal productivity. Who doesn't know? Again, immune system in swine is unique. We can take a concept from mouse and human studies, yet we have to be careful that they're different. We know that nutrition has in link to endocrine, growth, and immune response. Then also, we know that the immune response has linked to growth because if the protection response is too robust, that happens even the death. But also, this is too weak. The response is too weak, and there's a problem as well. And when stressor comes into the position in this figure, it gets much more complicated. But I must say that it's not impossible to come up with some prediction and perhaps the solution, because now we know a lot more about how it works. Probably the take-home messages are, we are in need for better and solid models to study stress in pigs. And we need biomarkers for stress, perhaps combination of these effector molecules. What to do and what to consider? More research, but well thought and well designed. And perhaps think about multiple stressors. Whenever I think and see the winning, that's not just one single stress. To me, that's multiple stressors. But still, I think that diet could be able to reduce the stress, but only when properly targeted. I'll not go into much of these point of views because of time constriction. I promised friends to finish on time, beat the clock. Vaccines and inflammatory responses are often needed in animals to keep the healthy status. And I won't be here without my students in the group. I thank you for that. Thank you very much for your attention.
Thank you, Professor Yun, for covering such a comprehensive topic in just 15 minutes. Finally, it was 17, but that's really fine, really highly interesting, and there might be some questions.
Thank you for the really good presentation, Professor. Question for you. There is a lot of research out there in immunomodulation, in nutritional, how you approach that from a nutritional aspect. There's a lot of work in isoflavins, in some essential oils as well. I would like to know your thoughts on how we can modulate the immune response from a nutritional standpoint.
I think Barbara explained a little bit about the phytochemicals. And again, I conclude that I still think that diet could work in certain extension, but we have to think about the causes first, whether we see the problem properly. Because what I see is that when we design the experiment, quite often we forget about these stressful conditions. And also when we use this anti-inflammatory reagent, that shouldn't have any conflict with other parameters like vaccination. If we do that, then I think that what we didn't see before from the studies we have done, I think if we revisit and carefully adjust, then I think we can find something that I still think that the diet can do in that part. Not like a medicine, but still, yeah, it's possible.
Okay, thank you. I saw another hand rising. Not so? If not so, then thank you again, Professor Yun.